Smasho here, welcoming you to the daily space weather. We've got the activity shifting to the southern hemisphere of the closest star, some plasma reorientation, coronal mass ejections, a new magnetically complex sunspot rising in the southeast, that and lots more. Coming at you from the Smash News Network, least busted name in news. Let's zoom out to show a full disk. There is an SDO calibration activity happening here. That's what that square feature is, the SDO making sure that it is perfectly centered on the solar disk. Also, a huge crown prominence has been hanging out around the northern hemisphere, right up here. I think that filament needs a name. What do you think? Join us on Twitter to name that filament. Here's a sunspot scenario, and we'll have looks like a mild uptick here in the sunspot number in the coming day, as this sunspot in the southeast is quite huge and quite magnetically complex. Not sure how many umbrae it will have. It certainly has at least one very large one, and we'll show you some high-res imagery toward the end of the video about that. In between the space weather and bonus features segment. So there's your colorized magnetogram. That's yesterday plus today from SDO. By the way, if you enjoy the content, press like, subscribe, share, etc. Tell your friends and foes about us. We do not trust big tech to be looking out for our best interests, or yours, for that matter. Certainly, the pathetic shadow bans continue on the internet, and that's part of the reason why we created our own web ring in the first place. So, back in 2018, we noticed pathetic censorship on Facebook, and so we decided to create smashomash.com. So help us out with clicks, click our links, etc., pick up some merch, give Smash staff a raise, become a patron, or better yet, become a member of the Smash team. Smashomash.com/Smash team is the official subscription services site for the channel. You can also find links there to our Hemp Lucid shop. So do yourself a favor by pressing subscribe, like, etc. Press the notification bell. You may even get notified, although we doubt it, that we will be putting up a video. Thanks for leaving a comment, TinMan1057. And let's get to the volcanic breakdown. Stromboli. It looks like it's been chilling out a little bit here. Looks like the lava advance has slowed and showed signs of cooling. No significant variations of volcanic tremor either at Stromboli. Shivaluch. Looks like an uptick at Shivaluch. Flight level 230. That's a 23,000-foot ash plume over the Kamchatka Peninsula. The Kamchatka Peninsula from Shivaluch. Abiko also erupting. Flight level 100. That's a 10,000-foot ash plume over Paramushir Island. Suwanosejima, 6,000-foot ash plume. Popocatépetl, 21,000-foot ash plume as it explodes. It is on my bucket list. Fuego in Guatemala exploding also. Nevado del Ruiz exploding. 16,000-foot ash plume over Fuego. 21,000-foot ash plume over Nevado del Ruiz in Colombia. Headed down to Ecuador. Sangay, a 21,000-foot ash plume as it explodes. Revenador, 15,000-foot ash plume as it explodes. Flight level 150. Flight level 230 over Cotopaxi. It is exploding as well. Flight level 230. Flight level 240 over Sabancaya in Peru. Please do not pole vault the caldera. There's your seismic activity over the past 90 days. And let's get to earthquakes. So it's been pretty calm here over the past 24 hours. Papua New Guinea did have a 5.3. This is a weird one in Australia. That's kind of in an abnormal spot to see a 4.7 magnitude quake. So seismic activity has been quite calm here over the past 24. And I mean, you could say that we are in an earthquake drought here. It's been a long time since a 7 magnitude quake. We are a little bit overdue for one. Chile had a 5.1. That came in at 23:23 Universal Time yesterday. That quake was at depth also at over 130 kilometers estimated depth there. And if we miss anything on our report, let us know in the comments. Vanuatu also had a 5.3, so it was a pretty calm 24 hours here, seismically speaking, and let's get back to space. Here is our house favorite wavelength. We like showing the 171 angstroms because it is certainly aesthetically pleasing. It makes the sun look lively, and it's great at showing the magnetic features of active regions. How about if we add 335 angstroms for a little additional depth? Okay, ask and ye shall receive. There you go. There's another species of ionized iron there showing up from SDO. Eyes on this sunspot down here. It is looking large and looking in charge. The 10.7 centimeter radial flux, now at 151 solar flux units. That radial flux comes from the upper chromosphere and lower corona. And it is a proportional solar feature to sunspot number. And you can see how the red line here is directly proportional to the black line. The red line is the sunspot number. The black line is the 10.7 centimeter radial flux. So NOAA here not forecasting any additional geomagnetic unrest or geomagnetic storm conditions here. We do have a very strong field for the past couple of days, currently at 15 nanotesla. We'll show more in-depth information on that, but first, we're going to do the cosmic ray report. So we haven't done cosmic rays for a while here. We're going to crisscross the globe and check out our favorite cosmic ray monitors, the ones that look like they're returning legit information. So here we go, DOMB Antarctica, showing a flat cosmic ray flux here. Maybe even a slight uptick over the past 30 days. DOMC Antarctica, showing a mild downtick over the past 30 days. So there's an interesting thing already, a variation in the cosmic ray flux detected at Antarctica. Let's go way up north to the land of Finland, to Oulu. Oulu seeing a mild downtick, nearly flat for the past 30 days for cosmic ray flux. And let's go way down south to Mexico City. So there's Mexico City, almost flat on the past 30 days. Maybe a mild downtick at Mexico City. Let's go back north to Greece. Greece, it looks like a tiny uptick over the past 30 days. So nearly flat. Generally, we're seeing flat cosmic ray flux here. Whoops. And last but not least, let's go back way up north to Apatity and Barentsburg. So Apatity showing a sharper decline in cosmic ray flux over the past 30. That's the biggest downtick of any detector that we've shown. And Barentsburg also showing a rather sharp downtick. So that's your cosmic ray report. Most monitors there showing up as a flat past 30 days. And let's take a look at global geomagnetism next. So the planetary K-index currently only at 1.33, geomagnetically calm conditions indeed. Let's take a look at Earth's magnetic moment from space for the past 4 hours as modeled by the Space Weather Modeling Framework. By the way, if you want to read about how it's generated, click on Details, that tab right there. That'll give you a link to the Space Weather Modeling Framework. You can download all the software and look at the raw data if you like. Little reduction there in pressure over the past 4 hours. Here's Earth's magnetic moment from the ground. This one is showing nanotesla magnetic flux density. It is also the last 4 hours. If you are a new viewer, congratulations on realizing the channel exists. Next, the real-time solar wind. We did see a little uptick there. That could have been a mild coronal hole impact. The density wave, if it was, we will indeed expect to see very soon an uptick here in the solar wind speed. Current conditions are, the fields are still kind of strong here. So if you look at the top pane, the BT-BZ is 16 nanotesla for the BT. The BZ is -9. And yeah, if we see a strong negative BZ signal there and an uptick in the solar wind speed, we will go into geomagnetic unrest conditions, perhaps, as we do see a negative BZ signal there emerging. So current conditions are about 8.5 protons per cubic centimeter. That's the solar wind density, solar wind speed, 357 kilometers per second, 357 kilometers per second. Let's take a look at some magnetic data. By the way, congratulations to the GOES 18. The GOES 18 now operational. So now we're showing the GOES 16 and GOES 18 instead of the GOES 16 and 17. Check it out. There's when it went live. At about 18:04 Universal Time yesterday. So a new instrument there. GOES magnetometers there in a normal operating range. Next, looking at the heliospheric current sheet. You can expect to see a North Pole current sheet showing up somewhere over here sometime soon. Come on, Epic Pen, you can do it. We're expecting to see a North Pole current sheet pop up someplace around here. Maybe in tomorrow's video you'll see it. It has to do with that very large sunspot in the southeast. Expect a North Pole current sheet headed this way soon. Not showing up yet on the top view ecliptic plane field plot. Here's our line of sight field plot. Solar B field here depicted in blue. Solar polar fields in red for south, green for north, and let's move to coronal holes. So here's our coronal hole line of sight plot. We've got quite a few south pole oriented coronal holes here, getting pretty close to the North Polar region there. So as the solar cycle progresses, you can expect to see more and more South Pole magnetism headed in this direction, and more North Pole magnetism headed in this direction. That could be considered the main feature of a solar cycle. Sunspot numbers perhaps are just an effect of the magnetic field reversal process. That's my story, and I'm sticking to it. Let's take a look at coronal holes from SDO. So here's SDO, 211 angstroms wavelength. And yeah, these are South Pole-oriented coronal holes here. That's a South Pole. This is South. This one over here is North Pole. That's what's going on in terms of coronal holes and solar polar field reversal processes. Did you know that we're composing a paper to explain the mechanism underlying these solar sunspot cycles and solar polar field reversal cycles? It's true, folks. We got started in earnest just yesterday. More information on that later. Let's go to sunspots. So here's the current sunspot situation. You can expect this one to be named 3182, Sunspot 3182. It looks promising. It's already produced at least one M-class flare, I believe. And let's take a look at sunspots here, a close-up from SDO. Here's a composite. And let's subtract the 171 angstroms to show the raw continuum. Oh, new sunspot forming down here also. So let's go back. This new sunspot, oh, that doesn't have a name yet. So that'll be 3182, probably. This one might be 3183. So we'll have two new sunspot groups. We'll definitely see an uptick in the sunspot number. See that group spontaneously forming there right by my mouse. It looks like it's beta gamma class, so likelihood of solar flares goes up a little bit along with the sunspot number. Here's a zoom out. We'll also show the SDO magnetogram here after that plays through. Bwah! There's the SDO magnetogram for you. That is the last 24 hours. Excuse me, and let's move to energetic particles and solar flares. No spikes in the proton flux here, so it's been a long time since we've seen a proton event. We are long overdue for one of those. Solar flares. Oh, that was on the C-class flares. We've only seen C-class flares. I thought they were M-class for some reason. The most recent one, a bit of a long duration flare, C6.85. Largest flare of the past 24 was this that's got to be larger. C class 9 point. Oh no, it would be about 8.5. Oh, that one's about a 6.8. So 6.8 and an 8.5, they did come from different regions, and let's take a look at that. The latest flare came from this region, sunspot 3183, I believe it'll be called. The earlier one came from this sunspot down here. And let's switch wavelengths to 131 angstroms. That's 94 there that you're looking at now. This is 131, the other wavelength for viewing solar flares. These wavelengths take 10 images per minute instead of only 2 images per minute. They are specifically designed to view solar flares. Next, moving to talk about what's going on overhead. We've got the moon having just set here over Lehigh Valley, Pennsylvania. That's our star chart. If you want to make your own, head to in-the-sky.org. We've got no planets. We've got no sun or moon near the ecliptic at the moment. It is dark and cloudy over Lehigh Valley, Pennsylvania. Next, a solar system forecast as we approach the January full moon. Let's do a 1-week forecast for the solar system as Earth is moving to the gas giant free side of the solar system. As where things will be in a week. Keep in mind this imagery is not to scale. We will have a gibbous waning moon on the 12th. And let's take a look at some coronagraphs. So it looks like we actually do see some energetic particles here striking the coronagraph. Right there. So perhaps some ejecta headed this way. So that's yesterday's imagery. That's 99 frames. Here's today's imagery. That's an additional 39 frames. I don't think those CMEs are earthly directed, though, so let's take a look at the view from Stereo A and Soho Lasco C3. So Stereo A is located out here at Lagrange 5. Soho Lasco C3 is at Lagrange 1. And for you new viewers, Earth would be off in this general direction from the... That was a terrible looking arrow. Earth would be off in this general direction from Stereo A. And frankly, if there is any ejecta headed this way, it's very diffuse. It may not even show up as a signal, depending on other interactions. There was a tiny little bit of plasma that looked like it could be earthly directed, but if so, it's very diffuse. So what I'm talking about is okay, so right about here, that's about 1338 yesterday. Let's see what we have. There could be a tiny CME headed this way. We can expect that to arrive early in the day on the 8th. Maybe late in the day on the 7th, but I'd say early in the day on the 8th. You can expect to see a minor CME impact from that. Not to be confused with a major CME impact. And even in the event of a major CME impact, the sun is still not going to kill you, and neither is the galaxy. Terrible decisions by humans might kill you. The sun, not going to do it. So here is the last 24 hours zoomed way out. Of course, we said yesterday the likelihood of additional coronal mass ejections is nearly 100%. We'll get to the forecast for that. In a minute, let's zoom in a little bit. Most of that ejecta certainly not earthly directed. There may be a tiny component. Here's the full zoom. And let's move to filaments. Since we've got some major filaments, let's animate the Cerro Tololo, Chile, ground-based hydrogen alpha solar observatory. Massive number of filaments here. This one up here needs a name for sure. This filament up here, this crown prominence, that certainly needs a name. Will the Kanye West filament make it to the west side of the sun? Currently, Kanye West is in the east. That filament right there, we've named it Kanye West. So perhaps name this one up here as we play once again. And nobody plays along, but that's because of shadow bans and pathetic censorship on big tech platforms. Fascist organizations who mislead their investors. Let's take a look. Twitter, we've got 345 followers and 18.3 thousand tweets, daily original content, and our own web ring. Makes a lot of sense, right? Anyway, in any case, name that filament, especially this crown prominence. If you've got other filaments you'd like to name, mark up the image, drop us a line on Twitter at Smashomash. Let's replay that. Likelihood of additional coronal mass ejections, nearly 100%. Remember, folks, you don't need solar flares or even sunspots to see coronal mass ejections. We covered it repeatedly around the solar minimum of November 2019. If you weren't watching back then, where were you? Oh, you probably couldn't see the content, like most people are unable to see the content. Speaking of being unable to see the content, check out Eugene's content. Eugene the Philosopher. This is the guy who is co-authoring the paper to explain the mechanism underlying these solar sunspot cycles and solar polar field reversal cycles. Perhaps support him on Patreon. It'll make a difference. Eugene is located in Minsk, Belarus. So help him out. Press subscribe, press share, like, etc. Perhaps help him out on Patreon. Shout out to Eugene the Philosopher, the greatest living philosopher since the unfortunate passing of Robert de Nameland. Press like and subscribe if you enjoy the content on our channel. Tell your friends and foes about us. Visit our playlists if you haven't. There are hundreds of cosmology videos. Also, all kinds of other playlists like the 12 Days of Smashmas, Driving, Riding, and Pro Tips, Ownage, Food, and Drink. And don't forget Terms Defined, The Diamond Anvil Too Hard to Smash, and Smashomash.org presents The Sun. Thanks to our viewers for tolerating the pathetic, disgusting, and putrid censorship on big tech platforms. If you want to support the channel via some merch, check out the links below the video and on the homepage at smashomash.com to the merch. We recently released a new one, Because Reasons. We might even release another version of Because Reasons and remove all of the provocative imagery on it and just have the lettering, Because Reasons. Why? Because reasons. Why have you survived global genocide so far? Because reasons. Why don't you believe nonsense on the internet? Because reasons. Congratulations on surviving a global pandemic so far. And whatever you do, do not pole vault the caldera. I am wearing the... I'm not only Smash-O-Mash, but I'm also a client. Check it out. It's our top seller. Do not pole vault the caldera. It could be unhealthful, and we need the views on YouTube. So whatever you do not pole vault the caldera. If you're going through hell, keep going. Our finest days lie ahead. Sorry, civilization is simply not collapsing. As much as some people would like it to, it's just not happening. We keep getting comments about when the end of the world will be, and we keep responding with, we're not forecasting any such thing. You should be frightened of humans, not of nature. Humans are probably trying to actively undermine you right now. Nature? Not really. It's kind of neutral. So check out our top seller, Do Not Pole Vault the Caldera. A public service message from smashomash.org. Don't be like Steve Stimpak. Do not pole vault the caldera, folks. If you're going on a volcanic vacation, leave that vault pole at home. All right, so we're looking at the GOES 16 SUVi here for the past about 2.5 hours, and check out that crown prominence. Somebody name that thing on Twitter, would you? It's just splentacular. And let's zoom out a little bit here to show the full disc. This is what we typically stream on Twitch all day long, by the way. So check us out over there. Maybe install the mobile app, twitch.tv/smashomash. And this new sunspot group is definitely the most likely spot to see major flares here. Don't be surprised to see an X flare coming from that sunspot group. It is magnetically complex. We'll show you the high-res magnetograms here in a minute after our bonus features segment. So let's move on to said bonus features segment. At the moment, no charging hazards for satellites. It's smooth sailing there. Let's take a look at some more earthly bridge between space and Earth type weather. There is the GOES electron flux. That's measured at the F layer of the ionosphere. Once again, the GOES 18 now showing up. The red line is no longer the GOES 17. It's now GOES 16 in blue, GOES 18 in red. Electron flux here has dipped. And NOAA was way off with the forecast model here, seeing lower levels of electron flux than forecast. There is the 1-year graph to put it in context, now back toward the low end of the scale there for the relativistic electrons at the F layer of the ionosphere. And let's take a look at the F layer of the ionosphere. Again, it is one slice. The bridge between Earth and space is at about 300 kilometers of altitude. And we'll look at the vibrational frequency and the anomalogram. So there's the raw vibrational frequency, and we're seeing massive anomalies here. Huge low-frequency anomalies over Central Africa, the Central Atlantic, and the northern portion of South America. Also some wild swings there from high to low-frequency anomaly. You may not recognize it. You may not have realized that the South Atlantic anomaly is now in the South Pacific. Needs to be renamed. I'm officially renaming it the South Pacific Anomaly. Here's your anomalogram. And since the South Atlantic anomaly is now over here, let's officially rename it. It is now called the South Pacific Anomaly. Facts. We cite them on the channel no matter how controversial they are. So huge ionosphere anomalies there, including especially the low-frequency variety around Central Africa, the Central Atlantic, South America, and the South Pacific. So there it is. Right there's where the anomaly is located. You can easily see it right there near the 30 south latitude line. There is the vibrational frequency at 1145. There is the anomalogram at 1145. We'll also take a look at the total electron content forecast. This is the free electrons between your GPS satellite and your handset. It'll show you the most likely places to see GPS errors. So there's the latest image on the total electron content map from Australian Government Bureau of Meteorology. And here's the animated map. We're seeing quite chaotic electron flux here. Electron content here. This is typical when we see low levels of electron flux. So once again, huge GPS errors in perhaps unexpected locations like around the equator at nighttime, around North America in the wintertime, etc. That is the total electron content, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. Huge GPS errors all around the world as lots of electrons are currently out of place. Help us out with links. If you are unwilling and unable to open your cobweb-encrusted wallet, click our links below the video. Hit us up on social media. Let us know in the comments what your favorite social media is. We are on lots, and it does just this side of nothing to increase our subscriber count. You would think it would do something, increase our views, but not really, because, well, these platforms are similar to the platforms on a gallows. So do us a favor by clicking links, and do yourself a favor by clicking SureMed. Maybe become a member of SureMed. It's an association membership, not insurance, known as the American Better Health Organization, DBA SureMed. Its goal is to improve your health, and you can do so too. It's certainly worth the $20 a month for the doctors by phone, counselors by phone, virtual veterinarians, discounts on dental, vision, vitamins, labs, pharmacy discounts. SureMed, make me your agent of record, perhaps by becoming a member of SureMed via my link. If you're looking for Medicare insurance, drop me a line. I'm licensed in 28 states. Tell your friends and foes about SureMed. Also, send them my link if they're looking to improve their health. Lots of discounts there can do just that. I'm a member. Perhaps you should be one also. So let's take a look at this new sunspot. It is certainly interesting indeed. And it is officially beta gamma class. Too early to say if it's beta gamma delta class. This small group here that's recently formed is certainly beta gamma class also. Might even be beta gamma delta. Let's take a look. I'll say it's beta gamma delta. Am I going out on a limb? I don't know. Is anybody seeing this video? I don't know. There's your rock back. This group up here is not a sunspot. That is just a plage. Which brings us to the end of our space weather segment, which means it's time to head to meteorology. So the jet stream is in the news today, so let's talk jet stream. So first of all, the jet stream over the North Pacific is indeed quite concentrated. We've got 223 mile per hour winds there in the 250 hectopascal range. So a highly concentrated jet stream there over the North Pacific. Let's take a look at the polar jets. There is the northern hemisphere. I've heard the jet stream is straightening out. So I'm sure that'll create some sort of climate alarmism or other nonsense. Some people will say, the grand solar minimum is causing the jet streams to straighten out, or something like that, because of course it's the same feature that causes the jet streams to be wavy. Be frightened of it, folks, and make sure that you send them your cash, because they're really going to save you from cosmic scale disasters. Real likely. So here are the jet streams of the eastern world, and you can see they're blowing backward here over the western equatorial Pacific and portions of Oceania like Papua New Guinea, Indonesia, etc. Chaotic jet stream here over the southern hemisphere around Australia. Surface winds are looking like this. Surface winds of the western world looking like this. Jet streams looking like this. Not straight on this side of the planet at all. They are all over the place. And it's looking like a warm day in Vancouver. Some warm air there moving north. Chaotic jet stream here in the western world. Here's the central world. And what do you got? Doubled up jet stream over Europe. Chaotic jet stream in the southern hemisphere. Here is the surface wind scenario for this side of the planet. And let's get to some additional information here, like what's going on in terms of clouds and fog. This is clouds and fog over the Americas as the sun rises over the Atlantic Ocean. So that's what's going on over on this side of the planet. Shout out to our viewers from all around the world. Thanks for tuning in to the Smash News Network, least busted name in news. So here's our weather.gov map. And if your location is lit on the map, head to weather.gov and click your location to get your warnings. We scroll down to show the key briefly. We've got some winter storm warnings there in Utah. Also, eastern California. So let's do some forecasts. Once again, the jet stream is in the news. So let's drop a forecast here for the next 72 hours based on a GFS model for the jet stream. That's the 72-hour GFS forecast for the 250 millibar wind speeds. And here is the pressure and precipitation that will accompany that 72-hour forecast. Heavy precipitation there for the West Coast, otherwise known as the left coast. That's your 72-hour GFS pressure and precipitation forecast. We'll also show total accumulated snow depth change based on the same model, the 72-hour GFS. as an additional 2 feet of snow forecasted for large portions of California. And last but not least, total accumulated precipitation, as some of that will end up as rain. So some heavy rains there, forecasting about 6 inches of rain for portions of coastal northern California. That's a lot of moisture. Next, let's take a look at windy.com. And we're going to take a look at snow depth. So there is your current snow depth situation. We'll advance that 3 days. This is the European model. Here's where the European model puts snow depth at 2 p.m. on Sunday. And that reminds me, let's head to Global Cryosphere Watch, because we haven't looked at the overall state of snow here for a while on the channel. So let's take a look at that. Some more objective facts. So snow extent has dropped below the standard deviation. We're less than 1 standard deviation. We're below 1 standard deviation for snow extent. So that is just a 2-dimensional snow extent, folks. That's just literally the amount of area in terms of a 2-dimensional planet that snow covers. And we are more than 1 standard deviation below normal there for snow extent for this time of the year. As far as snow water equivalent, we're well above 1 standard deviation above normal. And as far as snow mass balance, keep in mind that does not include mountains. Kind of in the operating range there. That's the blue area is the 1982 to 2012 range. And here's the snow cover map if you're wondering about that. That's what's going on for the Northern Hemisphere. That snow extent is actually on the low side of things. Continuing on, by the way, if you want to see the live streams, drop us a line at twitch.tv/smashomash. What in the hell? I've gotten sidetracked here, folks. All right, so there's our windy.com map with snow depth. And here is our NASA GOES lightning mapper, and guess what? The GOES 18 has been declared the operational GOES West satellite. Figured I'd leave that on the screen for you there. The GOES 18, yes. Some heavy lightning there around the Isle of Hispaniola, just hanging out on the east side of the island there. And some significant lightning off the coast of the U.S. Also some Floridian lightning. Let's see if we've got any terrestrial strikes here at the moment. It doesn't look like it. But a strong thunderstorm there off the eastern U.S. coast. Here's the full zoom from lightningmaps.org. Next time you hear thunder, check it out. Shout out to blitzortung.org. Just a fantastic website there. And let's move on to our U.S. Doppler radar map. There is the full 50 states of AUSA, the allegedly United States of America. AUSA, yes, it's been renamed. You didn't know? We'll focus on the lower 48, as we've got a low pressure system here hanging out around Iowa, it looks like. And indeed, bringing some additional Great Lakes snow. Here is your shortwave radiation map showing clouds and fog. That low there certainly centered over Iowa. It should show up very clearly in the water vapor map. Here's the map that shows all the water vapor, and we've got a huge high pressure system here over southern Texas, Louisiana, and the Gulf. Likely clear skies over all of those areas there. Here's your recap. Vertical motion of water droplets in the air column. Shortwave radiation map showing clouds and fog. And last but not least, water vapor. That should clarify things. Thanks for tuning in to the Smash News Network, Least Busted Name and News. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Facts stated in this video suppressed by big tech for your convenience and your user experience. Opinions expressed in this video, not necessarily the opinions of Smash News Network, least busted name.